Joe, what are we looking at here?
These are storage bunkers for our aggregate. We have 10 mil chips, 20 mil chips, 6 mil chips and sand. This is where all the material starts its process in the concrete cycle. It's loaded in here.
Okay.
We have roughly 200 tonne of capacity here, 4 50-tonne bins.
Okay.
And that will be filled multiple times over the day.
Okay. Have you sensors on that to tell you it's dropping?
Exactly, yeah.
Okay.
There's sensors in it. There's also moisture probes in it to balance up the water content inside it.
Very good.
So this is where everything starts for us.
Okay.
And all our ingredients are sourced local. We have a quarry within 3 miles of the plant here, and they've been supplying our aggregate for the last 20 years.
Very good.
So that's Lynch's Quarries.
Yeah, excellent. We'll move on.
Okay.
So Joe, your reinforcing steel,
it arrives. Yeah, our reinforcing steel arrives in coils, 3-tonne coils, and it gives us the flexibility to be able to bend it into the shapes we want. So instead of ordering quantities of steel like we have in the stockyard there, we can bend as we want. So it's a just-in-time system.
Okay.
Cuts down the amount of quantities that we need to keep on site, and it also allows greater flexibility in our designs.
Okay. How many meters of
coil is in that?
Yeah, roughly.
About 2,000 meters.
Okay. Yeah. And you use varying sizes then?
Predominantly 16 mil, but yeah, we would use 8, 10, 12, and 16 mil coil.
Okay. Very good. So you have a machine then for bending this?
Exactly, yeah. We have a machine, it's called decoiler. So we have 2 decoilers on site here.
Yeah.
So we'll show them here. My trusted lieutenant is here.
What does this machine do?
It's a stirrup machine.
Right.
Basically, for every job, for every concrete job, there should be steel. So the stirrups is referred to the shapes of the steel, what's needed and what's necessary.
Right.
And we pipe it in here, and basically the machine does a lot of the work.
Okay. Feeding the coils?
Feeding in the coils.
Yeah.
Feeding the coils.
Okay.
It's modernising the game. Like before, it's all manual with the older stuff.
Right.
It's not the way anymore.
Yeah.
This is the way forward now.
Right. So higher output, better job.
Oh, 100%.
Yeah.
Yeah. 100%. Like to do a lot of this work manually might take 2 men.
Right.
And would take twice the time. This takes 1 man, and it's way quicker.
Okay.
It lessens everything.
Great.
How long have you been working that type of machine, Arthur?
I've been on these machines about between 5 and 8 years, roughly, or take.
Right.
You know, but I did a lot of the stuff previous by hand.
Okay.
You know.
So you understood the basics of it?
Oh, 100%,
inside out?
100%.
Yeah.
And being a steel fixer by trade, I'd know what everything is regardless.
Right.
You know?
Yeah.
So it's just a different side to the game.
Yeah.
Like, it's from the start to finish, really, like, you know.
And how important is it for consistency, say the standard bends and having them all the same?
Well, if you don't have it all the same, you create weaknesses, you know, because there's a reason for centres of steel, as in like 200, 100, 150 mil centres. Because if you don't, it creates weak points.
Right.
You know, consistency is always good with steel.
And steel is critical for concrete. So Joe, what's happening here?
This is where the fabrication of the box culverts cages goes on. Obviously, the lads are giving out a structural steel design from our structural engineer, and we prefab the cage here. More and more, we're starting to use these tie wire guns. It makes it a lot more efficient, a lot better tie, because we handle the cages after getting them into the mould. But as you can see there, it's
serious piece of kit.
Serious piece of kit.
Speed.
Speed, exactly, yeah. So they come with tying wire and everything, like a cartridge in it. So you just replace the cartridge with a brilliant job.
Yeah.
And it just allows the operator to be far more efficient.
And done better as well.
Exactly,
Tied better.
Exactly.
Yeah.
Okay. Great job.
Brian, what's the role of a structural engineer at Croom Concrete?
Basically, my responsibility is to ensure the compliance and design of all our structures with all the relevant structures for underpasses. So this is one of our basic cages that we've made for one of the smaller culverts. Here within the yard we have our own in-house design team. So when you're designing a culvert, especially a culvert or a box structure going under a road, there's some key rules we have to follow as this kind of a structural design team. So the first one will be kind of the set of Eurocode suites, which are kind of throughout Europe. We all engineers should be following the same kind of set of suites for design of all structures. But when you're dealing with specifically structures going under roads, there are a further set of suites that are really critical. So we're looking at documents such as PII guidance documents, and even more critically again, the PD 6694 document, which deals with the design of structures under roads. Now, as you see here, this is one of our smaller cages, but within the facility we have here, we have the capabilities of designing and manufacturing any shape and size of the box you need, and to suit your specific needs. Now, the critical thing is, the bigger you go, you have to consider the more steel you need. That's within a concrete structure. The key component really is your steel. So, on a smaller cage like this, we can use certain amount of lighter steel. But as your cage size grows and your box size grows, it's critical. It is a really critical factor, is the amount of steel that you have inside it, to ensure that number one, it's structural adequacy, and number two, that the durability of the structure really lasts in the long term. You know.
So when that's prepared, what do you do with them?
So next stage is it's taken into our molds. So this is one of our open molds here. So that reinforcing cage we brought in from next door, landed into our mold here. All cover is applied. So again, a critical thing with the design of these is the cover to the steel, to ensure the durability for the farmer in the long run. Like, especially in farm environments, it can be quite an aggressive environment with slurry passing through and all that sort of stuff. So we have to deal with that. And so when it gets to this stage, the cage is applied, and then our quality team come through, check everything is okay, make sure everything is ready for pouring, the mold is closed up, and our concrete is poured.
Okay. Do you apply oil to that before it's poured?
Yeah, all the shutters are applied with a release agent, just to ensure that it just pops off nice and easily the next day.
Very good. Yeah. So we're looking at a completed culvert here, I presume, are we?
Yeah, this is one of the units that was made yesterday. So
Okay.
it's been brought out, and as you can see now, these are units that have been wrapped in 2 coats of a bituminous epoxy resin.
Why?
So that's just it's a waterproofing agent essentially. So all our units can come with this as standard, or in some with TII regulations, sometimes you need to have certain sections of it with the 2 coats of what you see there, that black paint, the epoxy resin. And then there's a further membrane applied over the top of the culvert in situ. So we have that facility here to make them bespoke for each individual project.
Okay. So how long will that have to set before you can actually put it out in site? How long would you let it cure or whatever?
Normally what you'll be looking for is your 28-day strength with concrete, but here within our own, because we have our own in-house batching plant, we use a self-compacting concrete, which is accelerated strength inside it.
Right.
So we can actually turn these around quite rapidly for the client.
Okay. I see lots of cranes here.
Yeah, lots of cranes, lots
Big
of
part
noise,
of
lots of movement, yeah.
Movement, yeah.
So the way we've set up this manufacturing facility here is we have the capacity to do 8 units at a time.
Yeah.
And so just to give us that flexibility of movement, we have 3 cranes, gantry cranes inside here to allow us to cater to all molds at any one time.
What capacity have they, those cranes?
So we have 2 15-tonners and a 25-tonner.
Okay, yeah.
Yeah.
Very good. Brian, do you want to explain?
Yeah, so as you see, this is just a completed unit that was poured yesterday and is now being lifted out of the mould. So as you can see, it's a top-down fill to ensure a steel mould finish on all sides, so a nice smooth finish in the concrete on all sides of your culvert. When it gets to this stage, it's lowered here to the ground, and the lads using the spreader beam turn over the entire unit, so it's set ready to go onto your site.
Right, okay. So Joe, what's happening here now? Say, what quality control is going on here?
Yeah, every box that's made, we fill in what's called an ITP, an inspection test product for every product made. So our quality man here just checks the geometry of the box to see if it falls within specification.
Okay. And you'd say with a mould, there couldn't be much variation of.
There'll always be plus or minus 5 mil in the mould.
Okay. Yeah.
Typically, we're an ISO accredited company, so this is part of the stipulations of being that every precast product we make has got traceability. So that test reports that the quality man is filling in, that's full traceability, that product ever gives trouble in time to come or so forth. There's traceability there with us.
Yes.
It's extremely important. A lot of the products we supply are going on to national infrastructure projects, not just agricultural products, and traceability is massive.
You need it right.
Exactly.
Yeah.
You know, so it's like in anything.
Great.
It's required. And the other thing about the concrete we use here, there's none of this concrete fibre in it.
Right.
It's all self-compacting concrete. That is the reason we can lift it so quick. We can lift every product we can lift here within 16, 17 hours.
Okay.
And it gives it that white looking
And why
colour.
don't you need to vibrate it?
The vibrating concrete is cheaper,
Yeah.
but it was causing us a lot of issues with vibrations coming up with the hands,
Yes.
vibrator pokers getting caught inside in cages, and it was just the time. It was average to vibrate a culvert mold could take an hour, whereas with self-compacting concrete, there is no time to let. We can pour later in the evening, and it gives us faster turnaround of products.
So Joe, we saw where
This is
the
the-
aggregate,
yes.
the aggregate came in above. And
Yes.
We're looking at the underside of it now.
The aggregate is disposed of down into the hoppers here underneath.
Yes.
It goes onto what we call a weigh belt.
Yeah.
It goes from the weigh belt onto the main conveyor, and it travels from the main conveyor into the batch house.
Right. So are you making a batch depending on the mold then or the material you're making?
Exactly, yeah. So
what kind of size batches do you make?
typically about 1 cubic meter.
Right.
So we have 2 mixers. So we have one mixer for our dry cast equipment, which is our slap machines, our dry cast agricultural pipes, manhole rings, etc. And the second mixer we use for our wet cast, which is for the self-compacting concrete, which we use in our culverts and our bespoke products and our pre-stressed wall panels. So this is our batching house. As I said to you, we operate 2 mixers here. Our dry cast plant, which we use for our slats and all our pipes, agricultural products, that's all automated. But for our wet cast products, the operators come in, select their product, and it's automated batched out then. So typically we batch approximately 200 cubic meters of concrete a day, which equates to about 500 ton of concrete, roughly a day.
Yeah.
So, yeah, it's as I said, it's described. It's like baking here.
Yeah.
Everything we make is like baking a cake. So it's very important.
It's a key room here.
Yeah. So like calibration of equipment, making sure all our calibrations are up to date, are very important because we need to have consistency in our products.
Yeah. Understood. So have you one person then fully running this more or less here?
About a half a person.
Yeah.
A half a person.
Half time.
Yeah.
Whatever.
As I said, most of it is automated. The lads have all got call stations, so it's basically press a button and the concrete arrives.
Yeah. Great.
A manhole cover for a 2,000 gallon tank mold.
Right.
Tank that we produce. Very popular in underpasses. Do you know every underpass requires effluent storage?
Yes.
So that's a typical cover for our 9 cubic meter tank.
Yes. We're looking at your culverts here, so.
Yeah, this is our culvert stacking yard. We have approximately 2 acres here for storing culverts in. So we manufacture culverts from 1 meter to 6 meters predominantly. This is a 4 meter box here in front of us, 2.1 high. Will be very popular for man milking 300 cows. As in the back we have smaller culverts here. We do a precast wing wall system.
We saw last week there now on site when we did a video, so.
Very, once again, like Slurry Channel, very efficient, very fast install. You're getting better use out of your equipment on site and it speeds up the underpass installation massively.
Yeah.
Traditionally, we were supplying boxes and then the farmer or the contractor, the civil contractor was doing an in-situ wall, but it was all taking time.
Yes.
And on a public road, people want roads back opened as efficiently and safely as possible. So we offer them, very successful. We started manufacturing them about 4 years ago and they go hand in hand in our box culvert range.
Great.